Welcome to our third lab for DBMS. Let's take a look at the topics that we will be covering in this lab. So at first we will take a look at schema diagrams, then we will be taking a look at primary keys and foreign keys again. So we have already taken a look at primary keys in our previous lab, but we'll take some additional look at it in this lab again. Next, we will take a look at some alter statements which can be used to modify the structure of our tables. So we will see how we can add columns or delete columns, how we can add different kinds of constraints, how we can modify columns, how we can drop constraints, and so on. Right? And finally, we will end our discussion with taking a brief look at Cartesian product between tables. So without further ado, let's begin. So in the previous lab, if you guys remember, we have already seen how we can use primary keys, right? So we know how primary keys work. We know that primary keys are essentially type of constraints that we impose on the table so that we have a unique column in our table, the value of which can be used to uniquely identify each row in our table, correct? So if I were to have a table called instructor like this, let's say we have an instructor table. Let's say we have entries like, or columns like instructor ID, name, age, right? Now, let's say we want to uniquely identify each row in the instructor table. We can create a restriction, or we can create a constraint on this instructor table called a primary key. And we can define this instructor ID as the primary key, which will basically make this table uniquely identifiable, or make the entries of this table uniquely identifiable by this instructor ID, right? Now, we already know how primary keys work. So another kind of constraint that we will be taking a look at in this lab is the foreign key constraint, okay? So in case you guys have not studied what a foreign key is in your theory lab, let's see what it actually does, all right? Let's say we have another table called course. Okay. Now in this course table, we have columns like course code, credit, and we will have another column, let's say instructor. Okay. So course code is basically the course code of the course, obviously. And credit is the amount of credit that is assigned to that course. And now notice that we have another column called instructor here. And this instructor column is basically the instructor who is responsible for teaching a specific course, okay? Now notice that these two tables, that is the instructor table and the course table, both of these two tables have a common attribute or a common column. And that common column is this instructor ID in the instructor table and the instructor column in the course table, right? Because both of these columns are essentially holding the values of the instructor ID. Now, this is where the foreign key constraint works. Also, before I forget, in the course table, the course ID is the primary key. Now, anyway, getting back to foreign keys, the way foreign key works is like this. Suppose whenever we are entering any data inside the course table, when we want to enter the value for the instructor column here, we have to make sure that that value of instructor is already present in the instructor table here, okay? So basically, we have to make sure that any value that we insert under this instructor column is already present inside the instructor ID column of the instructor table, okay? And that is basically called the foreign key constraint. And this constraint is imposed on this course table here, okay? Now, in database terms, we say that this instructor ID column is referencing the instructor ID column of the instructor table, okay? Again, the instructor column of the course table is referencing the instructor ID column of the instructor table, okay? And the diagram that we just drew here is known as a schema diagram. So just keep that in mind. Now, another important thing to remember in case of creating foreign key constraints is that you can only create foreign key constraints that references another primary key of another table. Okay, so for example, in this case, the instructor column of the course table is referencing the primary key, that is the instructor ID column of the instructor table. Okay, and as for how schema diagrams are drawn, this is how basically you draw schema diagrams. You have your multiple tables. In this case, we have two tables like instructor and course, and each of these tables may have their own primary keys and foreign keys. And whenever we actually create foreign key constraints, these foreign key constraints are drawn like this, where you have an arrow pointing towards the primary key that that column is referencing. Okay, so just remember that. Now, in case these things are not much clear to you guys yet, don't worry, it will become clear as soon as we take a look at an actual diagram or an actual representation of these two tables. All right. Okay, so let's say we have our instructor table first. And this table has 3 columns: instructor ID, name, and age. And just for simplicity's sake, let's say we have only 2 entries here: instructor ID 2 and instructor ID 3. Instructor ID 2 has the name XYZ, his age is 25, and instructor ID 3 has the name ABC, and his age is, let's say, 35. All right. And remember, instructor ID is the primary key here. Okay. Next, we have our course table. So let's draw this course table as well. And in this course table, again, we have 3 columns: course code, credit, and the instructor who is responsible for teaching that course. All right. And let's say we have 2 courses here: 4307, 4308. 4307 has a credit of 3, 4308 has a credit of 2. Now, when we are assigning the instructor value here, the way foreign key works is that it has to make sure that those values are already present inside the instructor table here. Okay, so for this instructor column, we can only insert the values of either 2 or 3. All right. Now, let's say this 4307 course is being taught by the instructor with course ID, or by the instructor ID 3. Okay. And similarly, the course with the course code 4308 is being taught by the instructor with instructor ID 2. Okay. Now, in case we have another course that has an instructor that is not present inside the instructor table, the foreign key constraint will make sure that you cannot enter any values like that, and it will throw an error. Okay, so for example, if we want to insert a value for, let's say, course code 4635 with credit 3, and let's say the instructor that we're trying to assign here has instructor ID 05, okay, this will not work because this instructor ID that is 05 is not present inside this instructor table here. And so this will throw an error whenever you actually try to write down this code in SQL in your Oracle database. So that is how the foreign key constraint works. So if we take a look at our lecture material here, you can see that we have a schema diagram here, a sample schema diagram. Remember, schema diagrams can be as elaborate as you want. So in this case, we have 3 tables: course, department, and teacher. And here you can see that course ID is the primary key for course, department name is the primary key for department, and teacher ID is the primary key for teacher. Okay, and again, as you can see, the course department is a foreign key in course table, which is referencing the department name column, which is a primary key of department in the department table. Okay, and similarly, teacher department is a column in the teacher table, which is a foreign key in the teacher table, and it is referencing the department name column of the department table, right? So basically, both the course table and the teacher table has a column that is referencing the department name column of the department table, all right? So just remember that whenever you draw schema diagrams, an arrow comes out from the foreign key of one table, and it points towards the primary key of the table that you are referencing. Okay, so that's how schema diagrams are drawn. Moving on, let's see. So far, we have seen how primary keys and foreign keys actually work, right? Now let's actually see these things in action in our actual Oracle table. So here you can see that I have already written down the commands for creating the instructor table and the courses table, right? So we have our instructor ID as the primary key in the instructor table and the course code as the primary key in our courses table, right? Now notice that we are using this syntax for creating primary keys, right? Now from this lab onwards, we are going to use a different syntax, or not exactly different, just a bit more useful of a syntax for creating primary keys. All right, so if you guys have noticed, I have used the term constraint quite a bit in this discussion of ours, right? Now, the reason I have been using this term is because both primary key and foreign key are actually restrictions or constraints that we impose on our tables, right? Also, constraint is a keyword when it comes to SQL. So whenever we actually violate the primary key constraint in your Oracle database, you will see that, or you have already seen that, we get an error that says error code something has been violated, right? But sometimes seeing that error message is not enough to actually identify which error is being or which constraint is being violated, right? So let's say that we want to be sure whenever we see an error code, we know that what kind of constraint is being violated, right? And the way we can do that is by naming our constraints into something that we are familiar with. And the way we can name our constraints is very simple. We simply write the constraint keyword followed by the name that we want to give to this constraint. So let's say for the instructors table, we want to name this constraint as instructor table pk. Okay, so that's the constraint of that we are naming to our primary key. That is the name of the constraint that we are assigning to our primary key constraint of the instructors table. All right. Similarly, we want to give a specific or a unique constraint name to our courses table primary key constraint as well. So let's name this as courses table pk. Okay, so whenever these constraints are violated in our Oracle database, you will see that now we will be getting an error code that says either instructor table pk has been violated or courses table pk has been violated. All right, so that just makes debugging a bit more easier. All right, so we have our another important thing about the constraints or the constraint naming like this is you cannot use the same name for multiple constraints. Okay, so basically you cannot use the instructor table pk name again for some other constraint for your other tables, right? So this would be wrong because in this case we are naming two different constraints with the same name. Okay, so this would not be correct. Anyway, we have created primary keys for our two tables. Now let's see how we can actually create foreign keys. Okay, now foreign key is a constraint that is imposed on the courses table, right? So basically on the instructor column of the courses table. And we need to make sure that any value that we insert under the instructor column is already present under the instructor ID column of the instructor table. So we say that this constraint is imposed on the courses table. And the way we can actually write down this constraint is, again, we write down the constraint keyword followed by the name that we want to assign to this constraint. In this case, let's say we are assigning the name courses table fk to designate foreign key. Anyway, followed by the keywords foreign key, and inside the parenthesis you define the column which you are basically defining as the foreign key. Here instructor is the column that we want to assign as the foreign key, so that's what we wrote here. And then we have to write some more keywords. So these keywords are references, then the name of the table that we are referencing, in this case, the table name is instructors. And again, in parentheses, we write down the name of the column of the table that this foreign key instructor is referencing. Okay. So here we simply write instructor ID. So let's just bring this into a new line. There you go. Okay. So let's see what just happened here. So we have named our constraint as courses table fk, and then we have our keywords foreign key followed by a parenthesis where we are defining the name of the column, which we are defining as the foreign key here, that is the instructor column, followed by references keyword, and then we have the name of the table which we are referencing, in this case instructors, right? So instructors is the table that we are referencing, and inside the parenthesis here we are mentioning the column, the primary key column, which is being referenced by our courses table. Okay, so that is the inst ID column. All right, so that is how you actually create foreign keys. And if you look at our lecture material here, you can see that we have written down the syntax that you use to actually create foreign keys. All right, so now all we have to do is simply copy this commands in our SQL console. But we have a syntax mistake here, or a spelling mistake here. It will be REIGN. Okay, so yeah. So remember that most of the syntactical mistakes that you will face are due to spelling mistakes, right? So just keep that in mind. So anyway, let's create these two tables now. First, we create our instructors table, and then we create our courses table. Okay. Copy this and paste. All right. So one of the things that you'll actually come across, or one of the kind of errors that you will come across, is this column type incompatibility error. Okay, and let's try and understand why exactly we are getting this error here. Okay, so in the instructor column that we have defined inside the courses table, we have defined its data type as varchar2, right? However, when we take a look at the instructor ID column inside our instructor table, we see that this column, that is the instructor ID column, is defined as integer. Okay, now since we are defining this instructor column as a foreign key that is referencing the instructor ID column of the instructors table, both of these columns must have the same type of data, or that is, both of these columns must have the same data type. Okay, so we cannot define this as varchar2. Rather, we have to define this as int, or integer, so that it matches the data type of the column that we are referencing. Okay, so now when we actually create this table, you will see that we are not getting that error anymore because we have fixed our data type. Anyway, now that our two tables are complete, let's see and test whether our foreign key constraints are working or not. Okay. Right, so I have gone ahead and written down some insert statements that we will be using to insert some data inside our two tables. Okay, so let's say now we are going to insert these two entries in our instructors table. So yeah, that's our these two are the entries that we are going to be inserting in our instructors table. Okay, and there we have created two rows. Now our instructor table has two entries. Select star from instructors, and here you can see that we have an instructor with ID 2 and an instructor with an ID 5. Now let's go ahead and insert these two entries inside our courses table. Okay, you can see that both of these entries were successful, and the reason behind that is we inserted entries with values under the instructor ID column that are already present under the instructors table, right? So when we actually write down select star from courses, we get these two entries here, right? And again, we did not face any error because none of these values are violating the foreign key constraint. But now What happens if we try to insert this value here? That is a course with course code 4635, credit 3, but an instructor ID with the ID 7. Now, notice that the 7 is not present inside our instructor table, right? Here, you see that we only have 2 and 5. We do not have 7, right, under the instructor ID column. So theoretically, this should throw an error whenever we actually try to use this statement to insert any value in our courses table. So let's see if we actually get that error, okay? And there, you can see that we are actually getting that error, okay? And let's see what that error is actually saying. Integrity constraint test user.courses table fk violated, okay? So notice that it says courses table fk, and that is the name of the constraint that we had actually assigned to our foreign key constraint in the courses table, right? So by looking at this constraint name, we can easily understand that the foreign key is being violated, and we do not have to really worry about what other errors might be causing it. We can simply debug this error and move on, right? So that is the usefulness of naming your constraints to something that you are familiar with. It basically helps you identify what kind of error is being caused. So anyway, that's how foreign keys work. Hopefully you guys were able to understand how foreign keys work and will be able to implement them by yourselves as well. Now let's take a look at some other SQL statements that we will be learning in this lab. So we are basically going to take a look at how we can alter our tables or modify our tables after we have actually created them. So for example, suppose you have created a table, but later you realized that you need some additional columns in your table, okay? And the way you can do that is actually very simple. You simply write alter table keywords followed by the name of the table where you actually want to add any columns, and then you write the add keyword followed by the name of the column and the data type that you want to assign to that column, okay? So for example, in this course code table, or in this courses table, if I want to add a new column, say credit hour, I can do that simply by using this command that we just saw, right? So we can write something like alter table, then the name of our table, which is courses, followed by add, and then let's say we want to name this column as credit hour, followed by the data type of this column, which can be, let's say, number, okay? And there, table altered. And then when we describe this table, describe courses, we can see that we have an additional column here called credit hour, which has been added in our table, right? Similarly, we can also add additional constraints to our table. So for example, suppose you have created your table, but you forgot to add the primary key constraint to your table. All right, and then you can simply add that constraint by using this syntax here, which is alter table followed by the name of your table, and then you have the keywords called add, and then you basically write down the constraint that you're trying to add, okay? So constraint name, and then you simply add the constraints that you want to assign. Next, we have the command for deleting or dropping columns. So imagine you have already created a table, but then you decided that it has some useless columns that you want to get rid of. The way you can do that is by using the drop column syntax, okay? So here, if you want to drop the column credit hour again, all you have to do is drop, you basically have to write down the drop keyword, then you write down the column keyword, followed by the name of the column. So there, you have to write down this command to drop down to delete the column called credit hour from your courses table. And there, now it has been altered again. And now when we describe this table, you'll see that we do not have that column anymore. Now, one thing you need to remember whenever you actually use this command is any value that is present under that credit hour column that we just deleted, those entries are also going to be deleted. Okay, so be careful while using this drop column command. All right. Then you have another command called modify, and this modify this modify statement can be used to modify the data type of any column that you have defined. So for example, let's say you have created a column called ID and you have defined it as an integer data type, but later you realized that you need to combine both ASCII characters as well as numbers to define this data type or to define that column. And so you need to change the data type from int to something like varchar, right? And so you can do that very easily by simply writing modify followed by the name of the column whose data type you are trying to modify, and then simply write down the name of the new data type that you have there. Okay, so here I have already shown a demonstration of those of these alter statements. So in this statement we have added the semester column in our student table. Then we have defined this ID column of the student table as the primary key by using this alter table command again. And then we have dropped a column called name from our student table by using the drop column command. All right. So very simple things. I'm not showing these things in detail because these are actually very easy. Anyway, similar to dropping columns, you can also actually drop constraints, and that is also very simple. You simply have to write alter table followed by the name of the table. Then you write down the drop keyword followed by the name of the constraint that you are actually dropping. So this is another reason why you want to assign unique names to your constraint. This actually helps in dropping or adding new constraints, or basically dropping constraints that you are aware of. Okay, so if you do not have any unique name assigned to your constraint, you would not be able to drop constraints like this by using this command, right? So this is the reason, and some other reasons as well, why we actually want to assign constraint names to our constraints. Now, the last topic for today is Cartesian product. Now, we will learn a bit more about Cartesian product as well as join statements in our subsequent labs. But to make things easier, the reason we use Cartesian product is because we want to see data from multiple tables at once. Okay, so coming back to our instructor and course table, let's say you want to take a look at the values of the instructor table and the course table at the same time. The way you can do that is by doing a Cartesian product between these two tables. Okay, and the way you actually do Cartesian product is very simple. You simply write your select statement, and whenever you're writing the select statement, you simply write down the names of the tables that you want to merge, and you separate them by using a comma. Okay, that's it. That is how you do Cartesian product. Now, let's do a Cartesian product between our instructors table and our courses table. Now, before we actually write down that command, I want to emphasize something. How exactly does Cartesian product work? So let's say we have two tables. And suppose both of these tables have, or not both of these tables, let's say this table has 3 rows and this table has 2 rows. Okay, so 1, 2, 3, 1, 2. Now, when you actually perform Cartesian product between the first table and the second table, this is what happens. The first row of the first table is going to merge with the first row of the second table, and this will form a row itself. Okay, next, the first row of the first table is going to merge with the second row of the first table, and it's going to create us another row in your Cartesian product table. All right. Similarly, the second row of the first table is going to merge with the first row of the second table, and the second row of the first table is again going to merge with the second row of the second table. All right. And finally, the third row of the first table is going to merge with the first row of the second table, and the first row of the first table is going to merge with the third row of the first table is going to merge with the second row of the third table. Basically, each of the rows present in the first table is going to merge with each of the rows present in the second table and form new rows for your Cartesian product table. So if you have 3 rows or m rows in your first table and n rows in your second table, then the total number of rows that you will have after performing Cartesian product is going to be m by n. So in this case, we have 3 times 2, so we will get 6 rows. Okay, so let's actually see this in action in our SQL console. We simply right select star from instructors, courses, and let's resize this window. Here you can see that we have a total of 4 rows. Okay, 1, 2, 3, and 4. And the reason we have 4 rows is because we have 2 rows in our instructors table and 2 rows in our courses table, right? So 2 times 2 is 4, so we have 4 rows. Similarly, if we had, say, 5 rows in our instructors table and 2 rows in our courses table, we would have had 10 rows in our Cartesian product table. Okay, anyway, so that's how a Cartesian product works. So that's it for the topics that we were supposed to cover today. Hopefully you guys were able to understand everything. And again, everything that you will need to actually complete the tasks for this lab, you will find those things inside the lab lecture material that I will be providing to you guys via Google Classroom. Okay. So anyway, that's it for today. Take care. I will see you guys next time.